based on slope, we're going to be taking a look today at how do we know whether lines are parallel and or perpendicular or neither. And it's all about slope. So we're going to be taking a look at parallel and perpendicular lines, and we're going to do this based on slope. So if you ever see a question that deals with parallel and perpendicular lines, it's always dealing with slope, okay? It never matters how you draw them out or how they look. It's always a matter of slope. So that's my little 30-second rant there on making sure that we are understanding our parallel and perpendicular lines are based on slope. Now, when two lines are parallel, okay, or two lines are parallel, when they travel in the same direction forever, and will never cross or get any farther apart. Okay, so you might think of this as lines on a highway. Okay, they never cross each other, right? You have lines that just keep on going, that break up your lanes. They always keep going forever and ever. They are parallel to each other. They will never cross. They will never get closer or farther apart, at least if it was perfectly done. Okay, when two lines move in identical directions, okay, as such, they will have a common slope. And that's the important thing to remember. If two lines have the identical, okay, and we can put this identical, there we go, somewhat like that. Okay, when they have identical slopes, they will be parallel, but they must have identical slopes. Everything about their slope must be the same. Let's take a look at this example here. These three lines look like they may be parallel to each other. Based on what we see on the page, okay, it looks as though they are all going in the exact same direction, and we know that, at least on the page, they are not crossing. So let's figure out our slopes, and let's see if the slopes are, in fact, the same. Okay, so for A, okay, we're going to take a look at the rise and the run. For A, right here, we're going to, again, start on the left and move our way to the right. We're going to go down 3 spots, so that's our rise, -3, and we're going to go across 1, 2, 3, 4, 5, 6, 7, 8. Okay, we can simplify that. Well, that is simplified as -3/8. That is our slope for A. Now, if B and C are the same, that means then they are parallel to A, or if one of them is the same, it is parallel to A. But we need to go through and figure out, are B and C in fact the same? Remember, rise over run. For B, again, start on the left-hand side, go 1, 2, 3 down, so -3, so that part's the same. And then 1, 2, 3, 4, 5, 6, 7, 8. That is 3/8. So B and A are parallel because these are identical slopes. You'll notice the negatives are the same and the numbers are exactly the same. Now, does C follow the same pattern? Well, rise over run. And again, we're going to start on the left, so we go 1, 2, 3 down, -3. And 1, 2, 3, 4, 5, 6, 7, 8. -3/8. Okay, again, identical slope, meaning all 3 lines are parallel. Okay, so those 3 lines are all parallel. And the important thing again to remember here is that when the slopes are the same, the lines are parallel. If the slopes are not the same for whatever reason, even if it's off by 1 number, okay, if that was a 7 and that's an 8, that changes it completely, and they would then in fact not be the same lines. Okay, so it's important to remember that our slopes must be the same.